Right now, something about 85 miles wide is falling toward the inner solar system, and for almost the entire history of the human race, nobody knew it was there. It is the largest comet ever found. It is darker than coal, and it was discovered not by a telescope watching the sky, but by two scientists digging through years of old data who realized an object the size of a small country had been hiding in plain sight the whole time. Here is the twist. It will never hit us. It will never even come close. And that is the strangest part, because the real story is not this one giant. It is what this giant proves is still out there, unseen, at the very edge of everything. If you want to understand what is actually falling toward us, and why it matters far more than any impact scare, subscribe to the Sky Lab, because this is the kind of story we follow all the way down into the dark. Drop a comment and tell me where you're watching from, and whether a hidden shell of trillions of comets fills you with wonder or unease. Now let's get into it. Part 1. The Dark Thing. In the data. Somewhere out beyond the orbit of Saturn, in a part of the solar system so cold and so empty that sunlight barely reaches it, something enormous is falling toward us. It is darker than coal. It is wider than some entire countries. And for almost the whole of human history, nobody knew it existed. I want you to sit with that for a moment, because it goes against everything we tell ourselves about the age we live in. We map the ocean floor. We photograph black holes. We have machines on Mars right now scratching at the dirt. And yet an object roughly 85 miles across, an object with a mass of around 500 trillion tons, spent billions of years drifting toward the inner solar system completely unnoticed, hiding in plain sight until a couple of scientists went looking through old photographs and found it by accident. Its name is Comet Bernardinelli Bernstein. In the catalogues it is written as C, 2014, UN, 271, but almost everyone who talks about it just calls it the mega comet, because there has never been anything quite like it. It is, as far as we can measure, the largest comet ever found, and it is coming this way. Now before your stomach drops, let me say the thing I'm going to keep saying throughout this video, because it matters and because it is true. This comet is not going to hit us. It is not going to hit anything. It will never even come close. At its nearest approach, it will still be about 1 billion miles away, farther out than Saturn, and that will not happen until the year 2031. So this is not a doom story. There is no impact, no catastrophe, no countdown. But I would argue that what this comet actually is turns out to be stranger, and, in a quiet way, far more unsettling than any impact scare. Because the real story here is not the object you can see. It is what the object you can see is telling us about everything you cannot. Let me take you back to how it was found, because the discovery itself is a kind of ghost story. There is a project called the Dark Energy Survey. For years, a 4-meter telescope sitting on a mountaintop in Chile, at a place called Cerro Tololo, spent its nights photographing enormous patches of the southern sky, over and over, trying to understand the mysterious force pushing the universe apart. It was not looking for comets. It was looking at galaxies billions of light years away. But every night, as it stared out into deep space, it was also, without meaning to, catching much closer things drifting across the frame, faint things, slow things, things nobody had time to check. Two astronomers, Pedro Bernardinelli and Gary Bernstein, decided to go digging through that mountain of archived images, hunting for distant objects at the far edge of the solar system. And in 2021, in that pile of old data, they found a single faint dot that moved just slightly from image to image over a span of years. When they traced its path, they realized they were looking at something huge, something already active, something falling in from a distance almost beyond comprehension. And here is the part that gives me chills every time. Once they knew what to look for, they went back through even older archives, and they found it again, and again. There were photographs of this comet going all the way back to November of 2010. For more than a decade, telescopes had been quietly photographing one of the most extraordinary objects in the solar system, and it was just sitting there in the data, unrecognized, waiting for someone to notice. When those earliest images were taken, the comet was about 34 times farther from the Sun than the Earth is. To put that in plainer terms, it was near the distance of Neptune, out at the ragged frontier of the planets, and it was already bright enough for our cameras to catch it. Stop and think about what that requires. Neptune is so far away that sunlight out there is roughly 1,000th of what we feel on a summer afternoon. For an object that far out to show up at all in our images, when its surface is darker than coal and reflects almost nothing, it has to be gigantic. There is no other explanation. The faintness plus the distance plus the darkness only adds up one way. This thing is a monster. And I keep coming back to that word, unnoticed, because it changes how you see everything else. We did not detect this comet with some heroic new telescope pointed at exactly the right patch of sky, at exactly the right moment. We found it by looking backward, through data we already had, and realizing that the universe had been leaving us a message for years and we simply had not read it. Which raises an uncomfortable question. If something 85 miles wide can hide in our own solar system, in our own data, for over a decade, then what does that say about everything we have not thought to look for? That is the thread I want to follow through this entire video. Not the fear of the object, but the weight of the implication. Because the more you learn about Comet Bernardinelli Bernstein, the more you realize it is not really an exception. It might be the first clear glimpse of a rule. It might be the tip of something. I want to dwell on the discovery a little longer, because I think the way we found this thing tells you something important about the era we are living in. The Dark Energy Survey was not a comet hunt. It was one of the most ambitious mapping projects in the history of astronomy, an effort to photograph a huge swath of the southern sky over and over across 6 years, cataloguing hundreds of millions of distant galaxies, all in the service of understanding why the expansion of the universe is speeding up. To do that, it produced an ocean of images, a data archive so enormous that no human being could ever look through all of it by eye. And buried somewhere in that ocean, appearing as nothing more than a faint smudge shifting position from one night to the next across years of observations, was the largest comet anyone had ever seen. Finding it was not a matter of luck in the old sense, of an astronomer happening to glance at the right patch of sky. It was a matter of writing clever software to comb through millions of images, to link faint dots into moving objects, to separate the genuine distant travellers from the noise and the glitches and the countless background stars. Pedro Bernardinelli and Gary Bernstein were essentially panning for gold in a river the size of a continent, and what they pulled out was a nugget the size of a small country. That is what modern discovery increasingly looks like. The frontier is not always a telescope pointed at the dark. Sometimes it's a hard drive, and the courage to look again at data everyone assumed had already given up its secrets. And there is a quiet lesson in the fact that the comet showed up in images going back to 2010, more than a decade before anyone recognized it. For all those years, this object was not hidden by distance alone. It was hidden by the sheer volume of what we see, by the fact that we now collect far more of the sky than we can possibly examine. The universe was not keeping this secret from us. We were keeping it from ourselves, simply by not yet knowing how to look at everything we had already recorded. That should make you wonder, seriously, how many more of these are sitting in our archives right now, faint smudges that no one has connected yet, waiting for the right piece of code or the right curious mind to notice them. But to understand why this discovery mattered so much, you first have to understand just how absurd this object really is. And to do that, we have to talk about size, because the numbers are so large that they stop making sense. So let me try to make them make sense, because when you actually feel the scale of this thing, you start to understand why astronomers reacted the way they did, and why the moment they measured it, they knew the record books would never look the same. Part 2. How big is biggest? There is a temptation, whenever you hear the phrase largest ever found, to nod along and move on, because we hear superlatives constantly, and most of them are marketing. So I want to slow all the way down here and make you feel this one, because it is not marketing. It is one of the most lopsided records in modern astronomy. A typical comet, the kind that swings through the inner solar system and grows a pretty tail and shows up in the news, has a solid icy core, a nucleus, that is usually somewhere around 1 to 2 miles across. That is it. Most of the comets you have heard of in your life are, at their heart, a dirty iceberg a mile or 2 wide. Even Halley's Comet, the most famous comet in human history, the one that has been terrifying and inspiring people for thousands of years, has a nucleus only about 9 miles long. 9 miles. That is the celebrity of the comet world. Comet Bernardinelli Bernstein is about 80 to 85 miles across, roughly 129 kilometers. When the Hubble Space Telescope measured it, astronomers described it as being wider than the entire state of Rhode Island. It is around 50 times wider than a normal comet, and because volume grows so much faster than width, that 50 times wider figure turns into something staggering when you talk about mass. Its estimated mass is about 500 trillion tons. That is roughly 100,000 times the mass of a typical comet. Let me say that again, because 100,000 times is not a number the human brain handles well. If an ordinary comet were a single grain of sand, this thing by mass would be closer to a small building. It is not a bigger version of the same thing. It is a different category of object entirely, wearing the same name. Before this comet came along, the record for the largest comet nucleus belonged to an object discovered back in 2002, a comet with a nucleus estimated at around 60 miles across. That was the reigning champion for about 20 years, and then Bernardinelli Bernstein showed up and didn't just beat the record, it embarrassed it. We went from a 60-mile champion to an 85-mile behemoth, and unlike the old record holder, this one is still being watched, still being measured, still coming. Now here is a detail that I find genuinely eerie, and it is the thing I mentioned a moment ago. This comet is dark. When one of the lead scientists on the study described the surface, he did not say it was greyish or dusty. He said it was, quote, big and blacker than coal. The surface reflects only a few % of the light that hits it. It is one of the darkest kinds of surfaces in nature, closer to fresh asphalt or a lump of charcoal than to the bright, icy snowball you might picture when you think of a comet. And that darkness makes the whole story more incredible, not less. Because remember, we detected this object from more than 2 billion miles away, an almost black surface at a distance where sunlight is a feeble whisper, and we still caught it. The only way to reconcile those two facts, nearly invisible surface and still detectable across billions of miles, is for the object to be enormous. Its darkness is not a footnote. It is part of the proof. The comet is basically a mountain of very dark, very ancient ice, so large that even reflecting almost nothing, it still could not fully hide. Let me try a few more comparisons on solid ground, because I really want the width of this thing to land in your body, not just your head. Mount Everest, the tallest mountain on Earth, is a little over 5 miles from base to summit. This comet is around 85 miles across. That is roughly 15 Everests laid end to end. If you somehow set this comet down on the surface of the Earth, it would stretch across an area larger than many entire metropolitan regions, a single frozen object wider than the distance most people commute in a week. The island of Manhattan is about 13 miles long. You could line up 6 Manhattans across the face of this comet and still have room to spare. There is no human structure, no city, no engineering project in all of history that comes within a rounding error of this scale. We are talking about a single, coherent object, made almost entirely of ancient ice, that is genuinely the size of a small country. And it is worth pausing on what it means that this is the largest one we have ever measured, because records in astronomy usually get broken by a little. A slightly bigger star, a slightly more distant galaxy, a marginal improvement over the last champion. That is the normal pattern of discovery, incremental. But this comet did not nudge past the old record. It shattered it. The previous largest known comet had a nucleus around 60 miles across, itself an impressive object. Bernardinelli Bernstein is not a bit larger than that. It is dramatically larger, and its mass, because mass scales with the cube of the width, leaves the old record holder far behind. When a record breaks not by 10% but by a wide, uncomfortable margin, scientists take notice, because it usually means one of two things. Either you have found a true freak of nature, a genuine one-off, or you have stumbled onto the visible edge of a population you did not know was there. And as we will see, the evidence points hard toward the second answer, which is exactly what makes this comet so much more than a trophy. I want to give you one more comparison because I think it lands the point. We are used to thinking of asteroids and comets as city-sized or mountain-sized objects. The asteroid that ended the age of the dinosaurs was somewhere around 6 to 9 miles across. That single object, 6 to 9 miles wide, reshaped the entire history of life on this planet. Comet Bernardinelli Bernstein is roughly 10 times wider than the asteroid that killed the dinosaurs. Now, I'm not saying that to scare you because I promised you the truth, and the truth is that this comet will never come near us. I am saying it to calibrate your sense of scale. The objects that can rewrite planetary history are a few miles across. This thing is 85. It belongs to a class of object that, if it were ever on a collision course with a planet, would not just cause an extinction. It would be a world-ending event on a scale the inner solar system has not seen in billions of years. Let me also give you a sense of how astronomers even measured this, because the difficulty of it makes the achievement more impressive. You cannot simply point a telescope at this comet and see a disk. It is far too distant for that. What you see instead is a bright fuzzy blob, a glowing cloud of gas and dust, with the solid nucleus buried somewhere in the middle, like a streetlight lost inside a bank of fog. The actual solid core is a tiny invisible point at the heart of a coma tens of thousands of miles wide. So how do you weigh the streetlight when all you can see is the fog? The team that made the definitive measurement used the Hubble Space Telescope to take a series of sharp images and then did something clever. They built a computer model of the surrounding cloud, the fog, and carefully subtracted its glow from the picture, leaving behind only the concentrated spike of light at the very centre, the light coming from the solid nucleus itself. Then they compared that to earlier radio observations from a giant array of dishes in the Chilean desert. Put those two measurements together, and you can pin down both how big the nucleus is and how much light it reflects. That is how we learn two things at once: that it is enormous, and that it is astonishingly dark, darker than the earlier estimates had suggested. It is big, and it is black, and it took some of the best instruments humanity has ever built, working together, just to establish those two simple-sounding facts about an object billions of miles away. And I want to put that 500 trillion-ton figure into terms you can actually feel, because it is easy to let a number like that slide right past you. 500 trillion tons is roughly 100,000 times the mass of an ordinary comet, but compare it to things on Earth. It dwarfs the combined mass of every human being who has ever lived. It dwarfs the mass of all the concrete and steel in every city on the planet. If you somehow gathered up every mountain in a major range and weighed them together, you would still fall short. This is not a big rock. It is a small world, an icy planetoid that just happens to be on a cometary orbit, and the only reason we call it a comet at all is that it grows a coma and a tail when it warms. In terms of raw mass, it sits in a category closer to a minor moon than to the dirty snowballs we usually picture streaking across the sky. And that is exactly why its actual orbit is such a relief and such a fascinating puzzle all at once. Because an object this massive, falling in from this far away, could in principle have come in on any path. It could have been aimed anywhere. Instead, it is threading through the outer solar system on a track that keeps it politely, permanently, out beyond Saturn. It is a giant that keeps its distance. But before we get to that orbit, there is something even harder to explain about this comet, something that had astronomers scratching their heads the moment they found it. Because by every rule we thought we understood about how comets work, this object should have been a dead, dark, silent rock when we discovered it. It was so far from the sun that it should have been frozen solid and completely inactive, and yet it was already glowing. It was already alive, and that should not have been possible. So how was a comet lighting up in a place where there is barely any heat at all? That is where this story stops being about size and starts getting strange. Part 3. The Impossible Campfire. Here is a rule of thumb that held up for most of the history of comet science. A comet only comes alive when it gets close to the sun. That glowing head, that beautiful tail streaming behind it, none of that is the comet itself. It is the comet melting. As a comet approaches the sun, sunlight heats its surface, the ice turns straight into gas, and that escaping gas drags dust off the surface into a vast glowing cloud called a coma, and streams it out into a tail. No heat, no activity. The comet stays a frozen, invisible lump until it gets close enough to the fire. For the kind of ice that makes up most of a normal comet, water ice, that switch usually flips somewhere inside about 3 times the Earth's distance from the sun. Get closer than that, and the water ice starts sublimating and the show begins. Stay farther out, and the comet stays dark and dead. So now hold that rule in your mind, and look at Bernardinelli, Bernstein. When it was discovered active, glowing, wrapped in a coma, it was about 29 times farther from the sun than the Earth is. Not 3, 29. It was out near the orbit of Neptune, in a place where the sun is just another very bright star in a black sky, and it was already switched on. In fact, it holds the record as the most distant active comet ever discovered. Nothing else has been caught doing this so far out. Out there, at that distance, the temperature on the comet's surface is somewhere around minus 348 degrees Fahrenheit. That is unimaginably cold. It is cold enough that water ice is not just solid, it is as hard and inert as rock. Water ice out there is basically stone. It is not going anywhere. So the water ice, the stuff that powers most comets, was completely frozen and useless as a source of activity. And yet the comet was clearly active. Something was boiling off of it. Something was building that coma. The answer is that this comet was not running on water. It was running on something far more volatile, something that turns to gas at temperatures where water would not even flinch. The leading culprit is carbon monoxide, along with a family of what scientists call supervolatiles, ices so delicate that they sublimate. They turn straight from solid to gas, even in the brutal cold of the outer solar system. Where water ice needs the warmth of the inner solar system to wake up, carbon monoxide will start hissing off a surface out past Neptune, in temperatures hundreds of degrees below zero. And this is where the story gets beautiful, and also where it starts telling us something profound. Because those supervolatiles, the carbon monoxide and its cousins, are incredibly fragile. Any comet that regularly passes through the inner solar system loses them almost immediately. They boil away on the first close pass and never come back. So if a comet still has a healthy supply of carbon monoxide, still enough to build a coma out past Neptune, that tells you something extraordinary. It tells you this comet has almost never been warmed. It has not made this journey over and over. It is pristine. It is carrying ices that have been locked away, untouched, since close to the birth of the solar system. In other words, the very thing that makes this comet's early activity so puzzling is also the thing that makes it precious. It is active where it should be dead, and the reason it is active is that it is more untouched, more ancient, more perfectly preserved than almost any comet we have ever studied. It is worth understanding what that glowing cloud actually is, the coma, because it is one of the most beautiful and misunderstood features of a comet. The coma is not the comet melting in the way an ice cube melts in your hand. It is the comet outgassing. As those fragile ices sublimate off the surface, they rush outward into the vacuum, and they drag tiny grains of dust along with them. That escaping gas and dust forms an enormous, tenuous, glowing shell around the solid nucleus, a shell that can swell to be tens of thousands of miles across, far larger than the nucleus itself, sometimes larger than a planet. The nucleus of Bernardinelli Bernstein is about 85 miles wide, but the coma surrounding it is vastly bigger, a diffuse halo of gas and dust so large that the tiny solid core is completely lost inside it. That is exactly why measuring the nucleus was so hard. You're trying to find a dark speck buried at the center of a glowing cloud thousands of times its size. And there is a haunting image hidden in this. When you picture a comet, you probably picture something bright, even beautiful, a luminous head with a streaming tail. But strip away the coma, and the thing at the center is almost pitch black, one of the darkest surfaces in nature, a mountain of ancient carbon-rich ice that reflects almost no light at all. So the glow you would see, if this comet were close enough to see, is not the object itself shining. It is the object bleeding, a nearly invisible black giant wrapped in a luminous veil of its own escaping breath. The brightness is not the comet. It is the comet slowly, gently coming apart in the faint warmth of a distant sun, and that faint dismantling is the only reason we can find it at all. Astronomers have watched this activity grow as the comet has fallen inward. As it came from roughly 28 to 20 times the Earth's distance from the Sun, that surrounding cloud of gas and dust swelled dramatically, and more recently, using an enormous array of radio dishes high in the Chilean desert, scientists directly detected carbon monoxide gas streaming off the comet when it was still about 16.5 times farther from the Sun than we are. They did not just infer the activity from a fuzzy glow, they caught the actual molecule, the actual breath of this thing, from more than 1.5 billion miles away. Think about what that means as a piece of detective work. We are watching a mountain-sized block of primordial ice, older than the dinosaurs, older than the continents, exhale a gas so cold and so faint that it takes some of the most sensitive instruments ever built to detect it. across a gulf of space so wide that the light carrying that signal travelled for hours before it reached us. And from that faint breath, we can start to read the chemistry of the early solar system, frozen and preserved for 4.5 billion years. Let me make the physics of this really concrete, because I think when you understand what is actually happening on the surface of this comet, the wonder of it deepens. On Earth, we are used to ice melting into water and then water evaporating into vapour, a two-step process. But out in the vacuum of space, there is no liquid step. Ice does not melt. It sublimates, which means it goes straight from solid to gas, skipping the liquid phase entirely, the same way a block of dry ice on a table doesn't puddle. It just smokes away into nothing. And different ices sublimate at different temperatures. Water ice needs real warmth, the kind you only get in the inner solar system. But carbon monoxide ice is so volatile, so eager to escape, that it will sublimate at temperatures more than 400 degrees below zero. It is one of the most delicate, fleeting ices there is. That fragility is the whole point. Picture two blocks of ice sitting in a freezer. One is ordinary water ice, the other is carbon monoxide ice. Open the freezer door just a crack, let in the faintest breath of warmth, and the water ice will not even notice, but the carbon monoxide ice will already be hissing away. Now imagine that freezer is the outer solar system, and the crack in the door is the feeble, distant warmth of the sun seen from beyond Neptune. That tiny bit of warmth is nothing to water, but it is more than enough to wake the carbon monoxide, which is why this comet can put on a show at a distance where an ordinary comet would be stone dead. And here is the consequence that makes astronomers lean in. Because carbon monoxide is so easily lost, any comet that has passed close to the sun even a few times would have boiled all of it away long ago. A comet that still has a rich supply of it, enough to build a coma out past Neptune, has to be a near-virgin object, something that has almost never been warmed in its entire existence. So the activity is not just pretty, it is a certificate of authenticity. It is the comet proving to us that it is pristine, that it is carrying original, unaltered material from the dawn of the solar system, ices that have survived because they have spent 4.5 billion years in a place cold enough and dark enough to protect the most fragile chemistry there is. So the impossible campfire is not really impossible, it is just powered by a different fuel than we are used to, a fuel that only survives on objects that have been kept in the deep freeze for almost the entire age of the sun. Which naturally leads to the next question, the one that turns this from a story about a single strange object into something much bigger. Where has this thing been kept? What kind of freezer stays cold enough and lasts long enough to preserve carbon monoxide ice for billions of years? Because to answer that, we have to leave the comet behind for a moment and follow its orbit outward into a part of the solar system so vast and so dark that, until very recently, we were not even sure it was real. Part 4. The orbit that measures time in millions of years. Every object that orbits the sun traces a path, and the shape of that path tells a story. The planets travel in near circles, all of them lying in roughly the same flat plane, like marbles rolling around on a tabletop. That flatness is not an accident. It is a fossil of how the solar system formed out of a spinning disk of gas and dust. Anything that formed with the planets tends to move with the planets in that same thin shared sheet. Comet Bernardinelli Bernstein does not move like that at all. Its path is not a gentle circle in the plane of the planets. It is a long, steep, plunging ellipse that comes diving in almost perpendicular to that plane, falling toward the sun from far above or below the tabletop, like a stone dropped from a great height onto a still pond. That single fact, the steepness of its approach, is one of the biggest clues to where it came from. Objects that fall in from every possible direction, from high above and far below the plane of the planets, are the signature of something that lives not in a disk, but in a sphere, a shell, a cloud that wraps around the entire solar system in all directions. And then there is the sheer size of the orbit, which is where the numbers stop feeling like astronomy and start feeling like scripture. The path this comet is on carries it out to a distance of very roughly 40,000 times the Earth's distance from the Sun. Let me try to translate that. The Earth is 1 unit from the Sun. Neptune, the outermost planet, is about 30 units out. This comet's orbit reaches out to something like 40,000. That is not 30, that is 40,000. Its farthest point from the Sun sits at roughly half of a light year away, a meaningful fraction of the distance to the nearest other stars, and a single trip around that orbit, one full loop, takes something on the order of millions of years. NASA has described its orbit as taking roughly 3 million years to complete. 3 million years. The last time this comet was anywhere near the inner solar system, our species did not exist. There were no humans, no cities, no language. Early human ancestors were just beginning to walk upright on the plains of Africa. This object has been falling, silently, through the dark, for the entire span of human evolution, and it is only now, in our lifetimes, arriving. Right now, as we speak, it is moving toward us at about 22,000 miles per hour. That sounds blisteringly fast, and by human standards it is. But against the immensity of the distance it has to cover, it is a crawl. It has been falling toward the sun for well over 1 million years just to complete the final leg of this approach. And it still is not here. It is worth pausing on what that 3 million year orbit actually means, because our minds are simply not built to feel a number like that, and I want to try to make it land anyway. 3 million years ago there were no modern humans. Our distant ancestors were early upright walking primates in Africa, using the crudest stone tools, with brains far smaller than ours. In the time it has taken this comet to complete a single loop of its orbit, an entire genus rose, evolved, spread across the planet, built language, agriculture, cities, and telescopes. Whole species of humans appeared and went extinct. Ice ages came and went, over and over. Continents shifted measurably, and through all of it, this one object was doing nothing but falling, silently, along a single arc, not even completing one circuit. When it was last in this region of the solar system, none of what we call human history or even human existence had happened yet. It is a clock that ticks once every few million years, and we happen to be alive at the exact moment it comes around. And the mechanics of such an orbit are worth appreciating too. An object on a path this enormous spends the overwhelming majority of its time out at the far, slow end, creeping along through the frozen dark where the sun's pull is at its weakest, moving so slowly that it can take hundreds of thousands of years just to round the distant turn. Then, as it falls back toward the sun, it gradually picks up speed, faster and faster, until it whips through the inner leg of its journey comparatively quickly before flinging back out again. So the decade or so during which we get to observe Bernardinelli Bernstein near its closest approach is the fast, bright, active sliver of an orbit that is otherwise almost entirely spent in slow, dark, distant silence. We're catching it during the one brief energetic act of a performance that is otherwise millions of years of stillness. Miss this window, and the next chance comes around long after our civilization, and quite possibly our species is gone. So where does all that falling end? This is the part that ties the whole thread together, and it is the part that I find genuinely poetic. This enormous object, the largest comet we have ever found, falling in from half a light year away on a 3 million year orbit, moving at 22,000 miles an hour, is going to reach its closest point to the Sun in the year 2031. And at that closest point, it will still be about 1 billion miles away from the Sun. It will come into roughly 11 times the Earth's distance just past the orbit of Saturn, and then it will turn around and begin the long climb back out into the dark. That is the paradox at the heart of this whole story. Here is the biggest comet ever discovered, and it will never come close. It will never cross the orbit of Jupiter. It will never be visible to your naked eye. Even at its brightest in the early 2030s, you will need a serious telescope to see it at all. It is a giant that arrives, gestures faintly from beyond Saturn, and leaves. Most people alive today will never know it passed. And there is something almost humbling in that. We tend to assume that the biggest, most dramatic objects announce themselves. That size means spectacle. But this comet breaks that assumption completely. It is a leviathan that will slip through the outer solar system almost in secret, witnessed only by our instruments, and then vanish back into the deep for another few million years. I want to linger on that word, perihelion, because it is the key to the whole paradox, and it is worth understanding properly. Perihelion is just the name for the point in an orbit where an object comes closest to the Sun. For the Earth, perihelion is about 93 million miles, once a year, every year, like clockwork. For a typical bright comet, perihelion might be inside the orbit of Mercury, a scorching close pass that boils off huge amounts of ice and grows a spectacular tail visible from your backyard. Perihelion is where the drama happens. It is where a comet either puts on the show of a lifetime or falls apart trying. Now here is what makes Bernardinelli Bernstein so strange. Its perihelion, its closest possible approach to the Sun, the most dramatic moment of its entire 3 million year orbit, still leaves it out beyond Saturn, about 1 billion miles from the Sun. In other words, the closest this giant ever gets is farther than most comets ever start from. Its grand climactic moment happens in a region so cold and so distant that it will still barely register in our telescopes. It is as if the biggest performer in the world walked all the way to the edge of the stage, in the dark, at the back of an enormous empty theatre, and gave the performance of a lifetime to almost no one. And that steep, nearly perpendicular angle of its approach is worth pausing on too, because it is such a clean fingerprint. Everything that formed alongside the planets shares their flat plane, moving like traffic on a highway, all in roughly the same direction, in roughly the same lane. When you see an object come plunging in from far above or far below that highway, dropping toward the Sun at a steep angle from an unexpected direction, you're looking at something that does not belong to the highway at all. You're looking at a visitor from a place that surrounds the highway on all sides, a sphere rather than a disk. That single geometric clue, the angle of the fall, is one of the ways astronomers knew, almost immediately, that this comet was not a local. It came from somewhere far stranger and far larger than the familiar realm of the planets. Which brings us finally to the real question this whole video is circling. If this object spends almost all of its existence out there, in the deep freeze, half a light year from the Sun, falling for millions of years just to briefly visit the region beyond Saturn, then what is out there? What kind of place holds an object like this, keeps it frozen and pristine for the entire age of the Sun, and then, every so often, lets one slip loose to fall inward? To answer that, we have to talk about the largest structure attached to our Sun, a structure so vast that our fastest spacecraft would need tens of thousands of years just to cross it, and yet a structure that, to this day, no one has ever directly seen. Part 5. The Shell Around the Sun. In the year 1950, a Dutch astronomer named Jan Oort was puzzling over a strange pattern in the comets that visit our skies. He noticed that a certain kind of comet, the long-period comets, the ones that take thousands or millions of years to orbit, seemed to come in from every direction and from staggeringly far away. And he realized that to explain them, you had to imagine something almost unbelievable. You had to imagine that the Sun is surrounded far beyond the planets by an immense spherical cloud containing an unthinkable number of icy bodies, a reservoir, a nesting ground for comets, wrapping around the entire solar system like the shell of an egg. We call it the Oort cloud, after him. And I need you to understand just how big this thing is supposed to be, because it defies the imagination. The planets, all of them, from Mercury out to Neptune, occupy a cosy little region close to the Sun. Beyond Neptune there is the Kuiper belt, a flatter ring of icy worlds where Pluto lives. But the Oort cloud is on a completely different scale. Its inner edge is thought to begin at something like 2,000 to 5,000 times the Earth's distance from the Sun. Its outer edge may reach a quarter of the way, or more, to the very nearest stars, the Alpha Centauri system, several light years away. To feel that, try this. If you shrank the orbit of the Earth down to the width of a coin, then on that same scale the Oort cloud would be a sphere hundreds of feet across, and everything you have ever thought of as the solar system, all the planets, the Sun, the whole show, would be a tiny speck at the very centre. The Oort cloud is not a suburb of the solar system. In terms of sheer volume, it is the solar system. The planets are just the bright little core. And here is the part that borders on absurd. This vast structure, quite possibly the largest single structure gravitationally bound to our Sun, has never been directly observed. Not once. We have never taken a picture of the Oort cloud. We have never seen its bodies except in the rare cases when one of them, like our comet, comes falling inward. It is made of an estimated trillions of icy objects, but each one is so small, so dark, and so unimaginably far away that they are individually and collectively invisible to us. The largest structure around our Sun is, in a very real sense, a theory. A ghost we infer from the visitors it occasionally sends. Let that sink in for a second, because it reframes everything. When people say we have explored the solar system, what they usually mean is that we have explored the tiny bright core, the planets, and their moons. The overwhelming majority of the solar system by volume is this dark spherical shell that we have never laid eyes on. We know it is there almost entirely because of objects like Comet Bernardinelli Bernstein. Every long-period comet that falls inward is a messenger, a single grain of sand carried in from an invisible beach, and from those grains we try to reconstruct the whole shoreline. Let me build a scale model in your mind, because it is the only way I know to make the Oort cloud feel real. Imagine we shrink the entire solar system down until the Earth's orbit around the Sun is the size of a small coin sitting on a table in front of you. On that scale, the Sun is an invisible pinprick at the centre of the coin. Jupiter is a few coins away. Neptune, the outermost planet, the edge of what most people think of as the solar system, is about the width of your dinner plate from the centre. That is the whole familiar solar system, the planets, everything we have ever landed on or flown past, all of it fitting on your dinner table. Now on that same scale, where is the Oort cloud? It does not fit on the table. It does not fit in the room. The inner edge of the Oort cloud would be somewhere out past the walls of your house, and its outer edge would be blocks away, a vast spherical shell hundreds of feet across, with your entire dinner table solar system as a single glinting speck at the very centre. That is not an exaggeration for effect. That is roughly the real ratio. The planets occupy a plate. The Oort cloud fills a neighbourhood, and it surrounds the plate in every direction, above and below and all around, a genuine sphere rather than a flat disk. When you hold that picture in your mind, you finally understand why astronomers say we have only explored a tiny fraction of the solar system. By volume, the part we know is a speck at the centre of something almost unimaginably larger, and that shell, that neighbourhood-size sphere in our scale model, is thought to contain something like 1 trillion or more icy bodies, each one a comet in waiting. That is the reservoir Bernardinelli Bernstein came from. That is the population it represents. Not a handful of stragglers, but a vast, silent swarm of frozen worlds, defining the true outer boundary of the Sun's domain, the real edge of our solar system, so far out that it brushes up against the space between the stars. Just how far away is this shell? Consider our fastest emissaries, the 2 Voyager spacecraft, launched in the 1970s, now the most distant human-made objects in existence, tearing away from the Sun at tens of thousands of miles per hour. Those spacecraft, at their blistering speed, will not even reach the inner edge of the Oort cloud for another 300 years, and to pass all the way through it, from the inner edge to the outer, could take them as long as 30,000 years. 30,000 years to cross a single structure at a speed no human vehicle has ever exceeded. That is the scale of the place our comet calls home. So now the pieces start to fit together. The steep, perpendicular orbit that comes in from any direction. The 3 million year period. The pristine carbon monoxide ice that has never been warmed. The impossible distance. Every strange feature of Comet Bernardinelli Bernstein is exactly what you would expect from an object that has spent essentially the entire history of the solar system out in the Oort cloud, in the deepest, coldest, most untouched storage there is, and has only just now, for reasons we will get to, begun the long fall inward. I think it helps to understand how Jan Oort actually reasoned his way to this conclusion, because he could not see the cloud any more than we can. He was working purely from the behaviour of the comets that fell inward. He noticed that the long-period comets, the ones on those enormous multi-thousand-year or multi-million-year orbits, had 2 revealing habits. First, they came from all directions, not just along the plane of the planets, which told him their source had to wrap around the Sun in a sphere. And second, when he looked at where their orbits reached their farthest point, a suspicious number of them topped out at roughly the same enormous distance, thousands of times farther than the Earth. It was as if they were all falling in from the same distant reservoir. From those 2 clues alone, Oort deduced the existence of a vast spherical cloud of comets that no telescope had ever seen, and to this day, every giant we find falling inward, including Bernardinelli Bernstein, confirms that he was right. It is worth separating this from the other reservoir of icy bodies you may have heard of, the Kuiper Belt, because people mix them up constantly. The Kuiper Belt is the region just beyond Neptune, where Pluto lives, and it is a relatively flat ring, still more or less in the plane of the planets, out at maybe 30 to 50 times the Earth's distance from the Sun. It is comparatively close, comparatively well studied, and we have actually sent a spacecraft through it. The Oort cloud is something else entirely. a spherical shell hundreds of times farther out, so distant and so faint that it remains even now unseen. Short-period comets, the ones that return every few decades like Halley, mostly come from the flatter Kuiper region. But the true long-haul giants, the ones falling in from half a light-year away on million-year orbits, come from the Oort cloud. Bernardinelli Bernstein is very much one of the latter, a genuine deep-shell object, and that is a large part of what makes it so special. And I keep returning to that fact that it has never been directly seen, the Oort cloud, because I think we do not sit with it enough. We have photographed the surface of Pluto. We have flown past the edge of interstellar space. We have detected the ripples of gravitational waves from black holes colliding billions of light-years away. And yet the single largest structure belonging to our own sun, the shell that may contain the majority of the solar system's small bodies, has never appeared in a single image. We know it the way you know there is a room on the other side of a wall because you keep hearing footsteps, not because you have ever opened the door. Bernardinelli Bernstein is a set of those footsteps, unusually loud, and it is one of the clearest reasons we are so confident the room is really there. But this raises a genuinely deep question, one that took astronomers decades to answer. If these comets live way out there, in a shell that begins thousands of times farther from the Sun than the outermost planet, then how did they get there in the first place? Ice does not form that far out. There was never enough material that far from the Sun to build trillions of comets on the spot, so the Oort cloud could not have formed where it is, which means all of those objects, including our giant, must have come from somewhere else and been moved. Something had to build this shell. Something had to take trillions of icy bodies and fling them out into the dark. And the story of how that happened is, in its own way, the story of how the entire solar system was born and nearly torn apart in its violent youth. Part 6. How the Deep Freeze was built. To understand where Comet Bernardinelli Bernstein really comes from, you have to go back about 4.5 billion years to a time when the solar system was young, crowded and dangerous. The Sun had just formed, and around it spun a flat disk of gas and dust. Out of that disk the planets were coming together, grain by grain, collision by collision. But the disk did not only build 8 tidy planets, it also produced a vast swarm of leftover icy bodies, comets in the making, out in the cold region around the young giant planets, Jupiter, Saturn, Uranus and Neptune. And the early solar system was not the calm clockwork place we see today. The giant planets had not settled into their final orbits yet. They were shifting, migrating, their immense gravity stirring the region around them like spoons in a bowl. And any small icy body that wandered too close to one of those giants got flung. A close pass with Jupiter or Saturn could grab a comet and hurl it outward with tremendous force, like a slingshot, sending it careening away from the Sun on a wildly elongated new orbit. This happened not once, not 1,000 times, but to an almost countless number of icy bodies. The giant planets, in their restless youth, acted like a gravitational pinball machine, taking the icy leftovers that formed near them and scattering them outward in every direction. Most were thrown into enormous looping orbits reaching far beyond the planets. Some were thrown clean out of the solar system entirely, lost to interstellar space forever. But a huge population landed in between, flung far enough to reach the frozen outskirts, but not quite fast enough to escape the Sun's grip entirely. And out there, in that cold and distant limbo, something gentle took over from the violence. At those enormous distances, the pull of the Sun is so weak that other forces start to matter, the faint gravitational tug of the rest of the galaxy, the occasional nudge of a passing star. Over hundreds of millions of years, those subtle influences worked on the scattered comets, lifting and rounding their orbits, pulling them up out of the plane of the planets, and smearing them into a great spherical shell surrounding the Sun in every direction. The flat, violent, scattering disk slowly became a round, quiet cloud. The Oort cloud was born, not where its comets formed, but where they came to rest after being exiled. Astronomers have built detailed computer models of this chaotic early period, and they paint a genuinely dramatic picture of a solar system that was, for a time, rearranging itself. In these models, the giant planets did not simply appear in their current orbits and stay put. They shifted, sometimes substantially, their gravity locking into rhythmic patterns with one another that amplified their effect on everything around them. As the giant planets migrated, they ploughed through the swarm of leftover icy bodies like ships through a field of ice, and the gravitational encounters flung those bodies in every direction. Some were hurled inward, toward the Sun and the young rocky planets, in an era of heavy bombardment whose scars we can still read in the craters of the Moon. Others were thrown outward, and it is those outward-flung survivors, caught in that narrow band of speeds too slow to escape, but fast enough to reach the frozen outskirts, that became the Oort cloud. What I find striking about this is how much it reframes the comet in front of us. Bernardinelli Bernstein is not some alien intruder or a leftover from a separate process. It is a piece of debris from the single most formative event in our solar system's history, the assembly and settling of the giant planets. It is a survivor of the bombardment era, a chunk of the raw material that did not become part of a planet, but was instead exiled to the edge and preserved. In a sense, every giant comet from the Oort cloud is a witness to the birth of the outer worlds, carrying in its frozen body the memory of a time when Jupiter and Saturn were still finding their places, and the whole solar system was a far more violent and unsettled place than the serene clockwork we see today. So here is the profound thing about a comet like Bernardinelli Bernstein. It did not form out in the Oort cloud, it formed much closer in the region of the giant planets, out of the same material that built the outer worlds. It is, in a real sense, a sibling of the planets, made from the same primordial stuff at the same time, and then, in the chaos of the early solar system, it was thrown out, exiled, banished to the deep freeze where it has waited essentially unchanged for 4.5 billion years. That is why these comets are so scientifically precious. They are not just old, they are samples of the original building material of the solar system, flash frozen at the moment of the planet's birth, and then stored, untouched, in the coldest, darkest, most stable warehouse imaginable for almost the entire history of the Sun. A comet that regularly visits the inner solar system gets baked and altered on every pass, its original chemistry cooked away. But a comet from the Oort cloud, arriving for what may be the first time in millions of years, still carries the unaltered recipe. It is a message in a bottle from the solar system's birth. And this is where I want to reconnect the giant to its origin story, because it makes the whole thing feel even more staggering. When you look at Comet Bernardinelli Bernstein, with its 85-mile-wide nucleus and its 500 trillion tons of dark, ancient ice, you're not just looking at a big comet. You're looking at a preserved chunk of the very disk that made Jupiter and Saturn, a fragment that was violently ejected in the solar system's turbulent youth and has been drifting in the dark ever since, keeping its carbon monoxide ice intact across a span of time so vast that the continents rearranged themselves. Entire species rose and vanished, and a small primate on a distant blue world evolved eyes and telescopes, and the curiosity to finally look back out and find it. There is a detail in this origin story that I find almost poetic, and it is worth spelling out. The comets of the Oort cloud are, in a sense, refugees. They were born in the warm, crowded, violent inner region near the giant planets, and then they were exiled, thrown out into the cold and the dark by the very worlds they grew up alongside. Jupiter and Saturn did not just build themselves. In settling into their orbits, they cleared their neighbourhood, and the debris they swept away did not simply vanish. A great deal of it was flung outward, and a fraction of that found the one narrow range of speeds that would carry it far out toward the stars without escaping the Sun entirely. Those are the survivors. Those are the ones that became the Oort cloud. Every long-period comet, including our giant, is a piece of shrapnel from the construction of the outer planets, still falling 4.5 billion years later, and the preservation out there is almost perfect, which is the second reason these objects are so precious. The Oort cloud is, without exaggeration, the best natural freezer in the solar system. It is far enough from the Sun that temperatures sit only a few tens of degrees above absolute zero, the coldest anything can be. There is no weather, no erosion, no sunlight to speak of, almost nothing to alter a body once it settles there. An object placed in the Oort cloud 4.5 billion years ago is, chemically, very nearly the same today as it was on the day it arrived. Compare that to the Earth. where the original surface has been recycled 1,000 times over by plate tectonics, weather, and life, until essentially nothing of the primordial planet remains at the surface. The Oort cloud kept its records. Our own planet burned most of its. So if you want to know what the raw material of the solar system was actually like, you cannot dig for it here. You have to wait for a messenger like this one to bring it to you, and the size of this particular messenger makes it even more remarkable in this light. It is one thing for a small comet to survive out there. It is another for an object 85 miles across, 500 trillion tons of ice, to have been thrown out to the edge of the sun's reach and preserved intact for the entire history of the solar system. That such a large body could be exiled at all speaks to just how violent the early solar system really was, and how much mass the young planets were hurling around in their turbulent youth. This is not a pebble that got flicked away. This is a mountain, a small world that was scattered into the dark and kept there, waiting. But that story leaves one crucial question dangling, and it is the question that turns this comet from an ancient artifact into a live event. If these objects have been sitting quietly in the Oort cloud for billions of years, in stable orbits, undisturbed, then why is this one falling toward us now? What woke it up? What reached into that distant shell, found this particular giant among trillions of frozen bodies, and set it on the long plunge inward? Because the answer to that question connects our quiet comet to some of the most dramatic events in the life of the galaxy itself. Part 7. What shakes the apples from the tree? Imagine a tree in an orchard, heavy with fruit, standing perfectly still on a windless day. The apples hang there, held in place, going nowhere. That is the Oort cloud in its resting state. Trillions of icy bodies held in enormous, slow, stable orbits, drifting through the dark for hundreds of millions of years without incident. Left completely alone, most of them would simply stay there forever. But the orchard is not always still. Every so often something reaches in and shakes the tree, and when it does, a few apples fall. In the Oort cloud, the falling apples are comets, and the shaking comes from the fact that our solar system does not sit in isolation. It drifts through a crowded galaxy, orbiting the centre of the Milky Way, surrounded by other stars, all of them moving on their own paths. And out at the edge of the Oort cloud, where the sun's grip is at its very weakest, the gravity of the wider galaxy is strong enough to matter. There are two main things that shake the tree. The first is the slow, steady pull of the galaxy itself, what astronomers call the galactic tide. As the solar system moves through the Milky Way, the combined gravity of all the distant stars and gas exerts a faint but relentless tug on the outermost comets, subtly stretching and tilting their orbits over millions of years. It is gentle, but it is constant, and given enough time it can slowly lower a comet's path until it begins to fall inward toward the sun. The second, more dramatic trigger is a passing star. Our sun is not a hermit. Over the long span of its life, other stars drift close in cosmic terms, coming within a light year or two, occasionally even closer. And when a star passes near the Oort cloud, its gravity yanks on those loosely held comets, like a hand thrust into the branches of the tree. A close stellar pass can send a whole shower of comets tumbling inward, knocked out of their ancient orbits and set on the long fall toward the sun. This is not just theory. Astronomers have identified stars that have grazed the outskirts of our solar system in the relatively recent past. One small red dwarf, sometimes called Schultz's star, is thought to have passed within about a light year of the sun, plunging through the outer edge of the Oort cloud only around 70,000 years ago. That is astonishingly recent in cosmic terms, right around the time our own ancestors were spreading across the Earth. And that star almost certainly disturbed comets as it went by, nudging some of them onto new paths that are only now, tens of thousands of years later, beginning to bear fruit in the inner solar system. There is a larger pattern hidden in this that scientists take seriously, and it adds another layer of grandeur to the story, because passing stars and the galactic tide act on the whole Oort cloud at once. A single close stellar encounter can dislodge not just one comet but many, sending a wave of them tumbling inward over the following hundreds of thousands of years. Astronomers call these comet showers, and they suspect the inner solar system experiences pulses of increased cometary traffic tied to the sun's slow journey through the galaxy, as it drifts nearer to and farther from denser regions of stars. In other words, the rate at which giants like this one come falling in is not perfectly steady, It rises and falls over immense spans of time, key to our solar system's passage through its galactic neighbourhood. We may, for all we know, be living in a relatively busy or relatively quiet stretch, and we would have no way to feel the difference on any human timescale. That connects our comet to something almost dizzying, which is the realization that the arrivals of these ancient objects carry information not just about the Oort cloud, but about the history of the Sun's encounters with other stars. Each long-period comet that falls inward is, in a sense, a delayed message from some past disturbance, a stellar flyby or a gravitational tide that happened long ago and is only now bearing fruit. If we could catalogue enough of them and trace their orbits back with enough precision, we might be able to reconstruct a rough history of which stars passed near the Sun and when. The comets become a kind of archive, a record of our solar system's social life among the stars, written in ice and delivered across millions of years. Bernardinelli Bernstein is one entry in that archive, a particularly large and legible one, and the census now beginning may eventually let us read many more. So when we ask why Comet Bernardinelli Bernstein is falling toward us now, the honest answer is that somewhere in the deep past something reached into the shell around the Sun and gave this particular giant a nudge. Maybe it was the slow tide of the galaxy, working over millions of years. Maybe it was the gravity of a star that passed near the Sun long before recorded history, a star that has since drifted on and may now be somewhere on the other side of the sky, a stranger that will never know what it set in motion. We may never pin down the exact cause for this specific comet, but the mechanism is clear, and it is humbling. The arrival of this object in our era is, in a sense, an echo of an encounter between our Sun and the rest of the galaxy, an encounter that happened before we were here to see it. I find that genuinely moving, and I want to make sure it lands. This comet is not just a big rock falling toward the Sun. It is a physical link between our solar system and the galaxy beyond it. Its very presence in our skies is evidence that we're not sealed off, that the Sun feels the pull of its neighbours, that the events happening among the distant stars ripple all the way down into our own backyard, sometimes taking millions of years to arrive. When you look at Bernardinelli Bernstein, you are, in a strange way, looking at the fingerprint of the galaxy on our solar system. There is a concept here that I think reframes how you see our place in the galaxy, and it is worth making explicit. We tend to imagine the solar system as a self-contained little island, sealed off from everything else, with the planets circling the Sun in tidy isolation. But the Oort cloud shatters that picture. Its outer edge reaches so far from the Sun, a meaningful fraction of the way to other stars, that it exists in a genuine borderland, a place where the Sun's authority fades and the influence of the wider galaxy begins to take over. Out there, a comet is only loosely tethered to us. It feels the tug of passing stars nearly as much as it feels the Sun. So the Oort cloud is not really the edge of a sealed island. It is a shared frontier, a region where our solar system blurs into the galaxy around it. And comets like this one are the traffic across that frontier, sometimes falling inward toward us, sometimes, over the eons, being stripped away entirely by a passing star and carried off into interstellar space forever. That last point deserves a moment, because it means the exchange goes both ways. Just as a passing star can knock a comet inward toward the Sun, it can also pull one loose and steal it away, sending it drifting off between the stars. Over the long life of the galaxy, stars have almost certainly traded comets back and forth this way, each system occasionally losing a frozen world to interstellar space, and occasionally, perhaps, catching a stray one from somewhere else. Which raises a genuinely mind-bending possibility that some of the objects in our own Oort cloud might not have been born here at all, but captured long ago from another star. We do not know that Bernardinelli Bernstein is a native, though everything about it suggests it is one of our own. But the very fact that the question is reasonable tells you how porous the boundary really is out there at the edge of the Sun's reach. So when this comet falls toward us, it is not just an event within our solar system. It is a small piece of a vast, slow, galaxy-wide process of gravitational give and take that has been going on for billions of years, a process we're only able to witness because, every so often, one of the countless objects caught up in it happens to fall close enough for us to see. Bernardinelli Bernstein is our front row seat to that process, a single, spectacular instance of the galaxy reaching into our solar system and stirring the deep. And that thought carries us straight into the next layer of the story. Because if this comet is a messenger, then the obvious question is, What is the message? What does an object like this actually tell us, now that it is finally close enough to study? What can we learn from a pristine 4.5-billion-year-old chunk of the early solar system that has just fallen back into the light for the first time since before there were humans to watch? The answer turns out to reach all the way back to the origin of the planets, and possibly to the origin of the water in the oceans you live beside, and it is here that this dark, distant object starts to feel unexpectedly personal. Part 8. A messenger from before. There were humans. There is a particular kind of vertigo you feel when you truly grasp how old some things in space are, and this comet delivers that vertigo in full. When you look at Comet Bernardinelli Bernstein, you're looking at material that has remained essentially unchanged since before the Earth had finished forming. Its ices, its dust, the very chemistry of its surface, all of it was locked in place around the time the planets were being assembled, and then it was banished to the deep freeze and left alone. It is quite literally a sample of the past that has been carried, intact, into the present. We have talked about deep time already in this channel, in our recent video on the dying supergiant star, where we sat with the strange fact that the light we see from a distant star may be showing us something that no longer exists, a picture of the past arriving in our present. This comet is the same idea made solid. It is not a picture of the early solar system. It is an actual physical piece of it, preserved and delivered. If you could somehow hold a fragment of this comet in your hand, you would be holding a substance that predates the oceans, predates the continents, predates life itself. And that is exactly why scientists are so eager to study it. Comets like this are, in effect, time capsules from the solar system's birth. By measuring what gases are streaming off Bernardinelli Bernstein, in what proportions, astronomers can read the original chemical recipe of the outer solar system, the mix of ices and organic molecules that was present when the planets came together. The carbon monoxide that powers its distant activity is a clue. So are the other molecules scientists hope to detect as it slowly warms on its approach. Each one is a data point about what the raw material of our world was actually made of. This connects to one of the great open questions in planetary science, which is where the Earth's water and organic molecules came from. Our planet formed hot and close to the Sun, in a region where it is not obvious that much water ice could have survived. One leading idea is that a significant portion of our water, and perhaps some of the carbon-based molecules that life is built from, was delivered later, carried in by icy bodies from the outer solar system. Comets and their cousins may have helped stock the young Earth with the very ingredients that made it habitable. So when we study the pristine ice of an object like Bernardinelli Bernstein, we are not just doing distant abstract astronomy. We are reading the composition of the same kind of material that may have helped fill the oceans and seed the chemistry of life. This dark giant falling in from half a light year away is carrying information about why our world is the way it is. Let me expand on that origin of water idea because it is one of the most intimate connections between an object like this and your own life, and it is genuinely unresolved science. When the Earth first formed, it formed hot, close to the Sun, in a region of the young disk where it is not at all obvious that much water ice could have survived the heat, and yet today, most of our planet's surface is covered in ocean. So a real question hangs over planetary science, one that scientists still argue about. Where did all that water come from? One leading idea is that a significant portion of it was delivered later after the Earth had formed, carried in by icy bodies from the colder outer solar system that were flung inward and struck the young planet, essentially watering it from space over millions of years. And along with the water, those same icy bodies may have delivered complex carbon-based molecules, the raw organic chemistry that life would later be built from. Now, the debate is not settled, and this is where studying pristine comets becomes so valuable. One way scientists test the comet delivery idea is by measuring the exact flavour of the water and other molecules on comets, the precise ratios of different isotopes, the slightly heavier and lighter versions of the same atoms. Think of it as a chemical fingerprint. If the fingerprint of comet water matches the fingerprint of Earth's oceans, that strengthens the case that comets helped fill our seas. If it does not match, then maybe other bodies, like certain asteroids, were the main water carriers instead. The measurements so far have been genuinely mixed and fascinating, with some comets matching well and others not, which suggests the true story is complicated, a blend of sources. And every pristine comet we can study, especially one carrying original unaltered ice like Bernardinelli Bernstein, adds another data point to that fingerprint library, Another clue in the mystery of how our world became a place where oceans, and eventually we, could exist. So when I say this dark giant is carrying information about why our world is the way it is, I mean that quite literally. Locked in its ancient ice is a record of the chemistry of the early solar system, the same era and the same kind of material that may have stocked the young Earth with the ingredients for life. We are, in a real sense, reading our own origin story in the breath of a comet that never comes closer than Saturn. There is something almost circular and beautiful in that. The material of the outer solar system may have helped make us, and now we, made partly from that material, are looking back out and studying a preserved sample of it. The comet and the astronomer studying it may be, in the deepest sense, distant cousins, both descended from the same primordial cloud. There is also the simple, staggering matter of what it means to catch one of these at all. Remember how far away the Oort cloud is, how our fastest spacecraft would take 300 years just to reach its inner edge and tens of thousands of years to cross it. We are never going to send a probe out to the Oort cloud to sample it directly, not in any time frame that means anything to us. The distances are simply too great, so the only way we will ever study the material of that vast shell is to wait for the shell to send its samples to us. And that is exactly what a comet like this is. It is the Oort cloud mailing us a package. We did not go and get it. It came to us, falling for millions of years, and now, for a brief window of a decade or so around its closest approach in 2031, we get to open it and read what is inside. And that window is precious in another way because of the comet's size. A big object survives its approach much better than a small one. Some comets, especially smaller or more fragile ones, break apart as they warm up, crumbling into pieces or fizzling out entirely. But Bernardinelli Bernstein is enormous, and its closest approach keeps it way out beyond Saturn, where it stays cold. It is very likely to survive its passage essentially intact. That means astronomers will get years, a sustained campaign of observations with our best telescopes, to watch this ancient giant slowly warm, brighten, and reveal its chemistry, all without the risk of it disintegrating before the story is done. It is a rare and generous gift of a research opportunity, a chance to study a pristine piece of the early solar system in detail, unfolding in real time. I want to underline just how unreachable the Oort cloud is, because it makes the arrival of this messenger so much more meaningful. We sometimes talk about human spacecraft leaving the solar system, and in a limited sense that is true. The Voyager probes have crossed the boundary where the sun's wind gives way to interstellar space, but that boundary is nothing compared to the Oort cloud, which lies vastly farther out. Those same Voyager spacecraft, the fastest, farthest-flung machines we have ever built, moving at tens of thousands of miles per hour, will not even reach the inner edge of the Oort cloud for about 300 years, and would need something like 30,000 years to pass all the way through it. 30,000 years is longer than all of recorded civilization. Many times over, there is no mission we could launch with any technology we can currently imagine that would fly out to the Oort cloud, scoop up a sample, and return it in a time frame that means anything to a human being. It is for all practical purposes permanently beyond our reach. And yet, here is a piece of it, coming to us. That is the quiet miracle of a long-period comet. We cannot go to the Oort cloud, so the Oort cloud occasionally comes to us. Bernardinelli Bernstein is doing for free, over millions of years of patient falling, what no rocket we could ever build would accomplish, delivering a genuine, physical, pristine sample of the most distant reservoir attached to our Sun right into range of our telescopes. When you frame it that way, this comet stops looking like a curiosity and starts looking like an incredible stroke of luck, a once-in-a-civilization opportunity to study material we could never otherwise touch. There is also something worth saying about the timing of its passage as a research event. Because the comet is so large and its closest approach keeps it so far from the Sun and so cold, it is not going to flare up and then quickly fade, and it is very unlikely to break apart. Instead, it will brighten slowly and steadily over years as it approaches, giving astronomers a long, patient window, a decade-scale campaign, to watch a pristine giant gradually warm and reveal, molecule by molecule, the chemistry it has been hoarding since the birth of the planets. Most astronomical events are fleeting, a flash, an eclipse, a flyby measured in hours. This one unfolds across an entire era of a scientist's career. A researcher who is a graduate student today could spend a substantial part of their working life studying this single object as it approaches, reaches its closest point, and departs. That kind of sustained access to a pristine Oort cloud giant has quite literally never been available before. So we have gone from a dark dot hiding in old data to a preserved fragment of the solar system's birth, carrying possible clues to the origin of our own water and the chemistry of life, delivered to us across a gulf we could never cross ourselves. That would be more than enough to make this comet one of the most important objects of the decade. But there is a final turn in this story, and in my view, it is the most important one of all. Because everything we have said so far is about this one comet, this single giant, and the truly staggering realization, the one that keeps astronomers up at night, is what this one object implies about all the ones we cannot see. Because Bernardinelli Bernstein was never meant to be understood as a single object. It is a clue, and the clue points to something enormous. Part 9. The Tip of the Iceberg. When astronomers announced the size of this comet, one of the scientists involved said something that at first sounds almost offhand, but the more you think about it, the more the ground seems to shift beneath you. He said that this comet is, quote, literally the tip of the iceberg for many thousands of comets that are too faint to see in the more distant parts of the solar system. Sit with that phrase, tip of the iceberg, because it is doing an enormous amount of work. What he is saying is that we should not think of Bernardinelli Bernstein as a freak, a one-in-a-universe oddity that we were lucky to catch. We should think of it as the first one we happened to notice, and there is a powerful piece of logic behind that, one rooted in how discovery actually works. Think about it this way. This comet is the biggest and the brightest of its kind, which is precisely why we were able to detect it at such an incredible distance, out past Neptune, more than a decade ago. Its very hugeness is what made it findable. Now in nature, big things are almost always rarer than small things. For every giant, there are usually many more medium ones, and vastly more small ones. It is true of boulders on a beach, of craters on the moon, of almost everything. So if the very largest, most detectable comet in the Oort cloud is already this big, then simple statistics say there must be a whole population of slightly smaller ones, and a much larger population of smaller ones still, all of them out there in the same shell, all of them too faint for us to have spotted yet. In other words, we did not find the one giant comet in the Oort cloud. We found the easiest one to find. And the fact that even the easiest one to find is a 500 trillion ton behemoth 85 miles across tells you that the shell it came from must be richer, more massive, and more crowded with large bodies than many of us assumed. Estimates for the total mass of the Oort cloud vary enormously, with some running as high as many times the mass of the Earth. And every giant comet we discover pushes those estimates and forces us to rethink just how much material is stored out there in the dark. This is why I keep saying the real story is not the object you can see. The object we can see, this one magnificent comet, is valuable in its own right. But its deepest importance is as evidence, as a single data point that reveals the existence of a vast hidden population. It is like finding one enormous footprint in the mud. The footprint is impressive on its own, but what it really tells you is that something large walks here, and that where there is one track, there are surely others you simply have not found yet. And this reframes that unsettling feeling from the very beginning of this video. The fact that something 85 miles wide hid in our own data for over a decade. Because now we can see that it was not a fluke of oversight. It was a preview. If a body this large can stay hidden until we deliberately go digging for it, then the smaller ones, the merely mountain-sized comets drifting in the same distant shell, are hiding even more easily. The darkness at the edge of the solar system is not empty. It is full. It is by some estimates home to trillions of icy bodies, and we have directly seen only the tiniest, brightest handful of them, the ones that happen to fall close enough at the right time wearing the right glow for us to catch. Let me put the raw numbers of our ignorance side by side because the contrast is almost comical. The Oort cloud is estimated to contain something on the order of 1 trillion or more icy bodies. That is a one followed by 12 zeros, a number so large it is essentially meaningless to the human mind. And how many of those bodies have we ever actually detected across the entire history of astronomy? A tiny handful, the rare few that happen to fall close enough, at the right time, to be caught. We have directly seen a vanishingly small fraction of a percent of the objects thought to be out there. If the Oort cloud were an ocean, we would not have mapped it, or sampled it, or even dipped a toe in it. We would have glimpsed a few droplets that splashed up onto the shore and from those few droplets we would be trying to describe the entire sea, and Bernardinelli Bernstein is the largest, clearest droplet we have ever caught. That is its true significance. Not that it is big, though it is staggeringly big, but that it is the best single sample we have from a reservoir we have barely begun to perceive. When you hold that ratio in your mind, a trillion unseen against a handful glimpsed, the humility becomes almost physical. We are not observers standing outside a well-mapped solar system. We are creatures at the centre of a vast dark shell, squinting outward, catching the occasional falling ember, and slowly, patiently, beginning to guess at the size of the fire. There is something both thrilling and deeply humbling in that. We like to think of the solar system as explored, as known, as a place with a finished map. But the honest truth is that the overwhelming majority of it, by volume and possibly by number of objects, remains completely dark to us. We have mapped the bright little core, the planets, and their moons, in exquisite detail. And surrounding all of it, in every direction, is a shell of trillions of frozen worlds that we have barely begun to perceive, a shell whose existence we confirm one falling comet at a time. Let me make the statistical logic even more concrete, because it is the heart of why scientists find this comet so significant. In almost any natural population of objects formed by collisions and chaos, small things vastly outnumber large ones. There are more pebbles than boulders, more boulders than hills, more hills than mountains. Astronomers describe this with what they call a size distribution, and for solar system bodies it is steep, meaning that for every giant there are enormous numbers of smaller siblings. Now we found Bernardinelli Bernstein first, and we found it precisely because its size made it the brightest and most detectable object of its kind, visible across billions of miles. But if the biggest, most findable one is already this enormous, the size distribution insists that there must be a whole spectrum of smaller ones out there, unseen, in numbers that climb steeply as the size drops. We did not find the needle in the haystack. We found the single largest piece of straw, and its existence tells us the haystack is far bigger than we thought. This directly feeds one of the great uncertainties in planetary science, which is simply how much stuff is in the Oort cloud at all. Because we cannot see it, estimates of its total mass have always been rough, ranging from a few times the mass of the Earth up to many times more. Every giant comet we discover, and especially one this large, pushes on those numbers, because it forces us to account for a population of big bodies we had not directly confirmed. And the total mass matters, because it is a direct record of how much material the young solar system flung outward during the era when the planets formed. The Oort cloud is in effect the discard pile from the construction of the planets, and weighing it tells us about the construction itself. A single comet like this one is a data point that reaches all the way back to how our world was built. I keep coming back to the footprint image because it captures the feeling so well. Imagine walking through a forest you believed was empty and finding a single enormous footprint pressed into the mud, far larger than anything you thought lived there. The footprint alone is astonishing, but the thing that actually raises the hair on your neck is not the footprint. It is the realization that where there is one track, there is a creature, and where there is one creature, there are almost certainly others, and that the forest you thought you understood is home to something you had never accounted for. Bernardinelli Bernstein is that footprint, pressed into the outer dark, and the forest is the Oort cloud, and the quiet, staggering message of it is that the forest is full. Comet Bernardinelli Bernstein, then, is not the end of a story. It is the opening line. It is the first clear word in a sentence the universe has been trying to say to us for a very long time. And the reason this particular moment in history is so extraordinary, the reason this comet arrived at exactly the right time to matter, is that for the first time ever, we are building the tools to hear the rest of that sentence. We are about to stop finding these giants by accident, one lucky dig through old data at a time, and start finding them on purpose, by the dozen. The age of stumbling upon the tip of the iceberg is ending. The age of mapping the whole iceberg is about to begin. And that changes everything about what the next decade of looking outward is going to reveal. Part 10. The census begins. For most of history, finding a comet was a matter of luck and patience. Someone with a telescope and a good eye would sweep the sky night after night, and every so often, if they were fortunate, a faint fuzzy patch would appear where none had been before. Even in the modern era, as we saw with Bernardinelli Bernstein itself, Some of our greatest discoveries have come not from watching the sky in real time, but from digging through mountains of old data, hoping to recognize something that was already there, already recorded, already missed. It has been, in a sense, an age of accidents. We found the giants we found because they were too bright to hide, and even then, we usually found them years late. That age is now ending, and it is ending because of a new kind of eye on the sky. High in the mountains of Chile, a new observatory has begun its work, one designed from the ground up not to stare at a single point but to survey the entire visible sky. Again and again, night after night, in extraordinary detail. It carries the largest digital camera ever built for astronomy, and its whole purpose is to notice change, to catch anything that moves or brightens or appears where nothing was before. Over the coming years, it will build a running movie of the southern sky, and it is expected to discover moving objects in the solar system in numbers that will dwarf everything found in all of previous history combined. What this means for our story is simple and profound. The faint, distant giant comets that have been hiding in the outer solar system, the members of that hidden population we have been talking about, are exactly the kind of thing this new generation of surveys is built to catch. We're about to go from finding an object like Bernardinelli Bernstein once in a lifetime, by accident, to potentially finding many distant comets, discovered on purpose, their orbits tracked from the start. We are, in other words, about to begin the first real census of the outer solar system. For the first time, we will be able to ask, not just is there a giant comet out there, but how many, how big, and how are they distributed, and actually get answers. And that is what turns Bernardinelli Bernstein from a single marvel into a genuine turning point. It arrived at the exact moment in history when we were finally building the tools to understand what it represents. A century ago, we could not have measured its size. A few decades ago, we could not have caught its faint breath of carbon monoxide from over 1 billion miles away. And even 10 years ago, we would have had no way to systematically hunt for its hidden siblings. Now we can do all three. This comet is a preview, a first specimen, arriving right as the machine built to find the rest of its kind switches on. There is a lovely rhyme here with other stories we have followed on this channel. A few weeks ago, we spent time with the asteroid Apophis, the space rock that will pass astonishingly close to Earth in 2029, and the real lesson of that video was not the flyby itself, but what it revealed about a whole population of objects we are still learning to track. Last month, we looked at the largest asteroid to pass Earth this decade, an object that had been quietly followed for years while questions about its true size and nature lingered. In every one of these stories, the pattern is the same. A single dramatic object turns out to be a doorway into a much larger, mostly hidden population, and each new discovery is teaching us how much of our own solar system we have simply never seen. Bernardinelli Bernstein is the grandest example yet, the biggest doorway, opening onto the largest and darkest room of all. Let me try to convey what a genuine shift this is, because I do not think most people realize that we are living through a quiet revolution in how we see the sky. For essentially all of human history, astronomy was the study of individual objects. You found a comet, you named it, you tracked it, you studied it, one at a time, like a naturalist cataloguing rare birds one by one. Discoveries were precious partly because they were scarce. But this new generation of survey telescopes changes the entire character of the enterprise. Instead of studying one object at a time, they photograph enormous swathes of the whole sky, again and again, night after night, and automatically compare each new image to the last, flagging anything that has moved or changed. The result is not a trickle of discoveries, it is a flood. These systems are expected to detect more moving objects in the solar system in their first years of operation than were found in all of prior human history combined. Think about what that does to a story like this one. Bernardinelli Bernstein was found by two people painstakingly combing through years of archived images, and even then, it took until 2021 to recognize something that had been recorded since 2010. That is discovery by heroic effort and a bit of luck. But in the new era, an object like this, faint and slow and distant, would be caught automatically, its motion flagged by software the first time it drifted measurably across the frame, its orbit refined night after night as the survey returned to the same patch of sky. We are moving from finding these giants by accident, once in a generation, to finding them on purpose, as a matter of routine. The needle in the haystack problem does not disappear, but we have built a machine that can search the entire haystack over and over tirelessly and hand us the needles. And the specific objects these surveys are especially good at catching are exactly the ones we care about here, the faint, distant, slow-moving bodies at the outer edge of the solar system. That is precisely the population that has been hiding from us, the smaller siblings of Bernardinelli Bernstein, the merely mountain-sized comets and icy worlds drifting in the same distant shell. For the first time we will be able to find them not one at a time, but by the dozen, and then by the 100, and from that growing catalogue we can finally start to answer the real questions. How many giant comets are out there? How are they distributed by size? How much total mass does the Oort cloud actually contain? These have been open questions for 70 years, unanswerable because we could only ever see the rarest, brightest visitors. Now, at last, we are building the statistics, one automatically detected object at a time. There is something almost democratic about this new era too. The data from these great surveys is often shared widely, and skilled amateur astronomers around the world play a real role in following up on new discoveries, refining orbits, and monitoring how objects brighten and change. Bernardinelli Bernstein itself has been watched by observers all over the planet, professional and amateur alike, ever since its announcement. So the coming census of the outer solar system is not going to be the work of a single secret institution. It is going to be a genuinely global, open, collaborative effort. Thousands of eyes and instruments trained on the dark, slowly building a map of a region we have only ever guessed at. And that openness matters, not just scientifically, but for reasons we will get to, because it is the exact opposite of the secretive, hidden picture that some people imagine when they hear about a giant object approaching. So the comet itself will be watched intensely all the way to its closest approach in 2031 and beyond, a rare decade-long opportunity to study a pristine giant in detail. But even as we watch it, the bigger project will be unfolding around it. The slow, systematic mapping of the shell it came from, the first attempt in human history to take a real inventory of the trillions of frozen worlds at the edge of the sun's domain. And as that inventory grows, so does the strangeness, because the more of these objects we find, and the more attention this one receives, the more a certain kind of story begins to spread. Not the careful, patient story that scientists tell, but a louder, wilder one, full of hidden agendas and secret dangers and things they don't want you to know. And I think it is worth meeting those stories head on, because tucked inside some of them is a real and reasonable question, even if the answer is not what the loudest voices claim. Part 11. The Theories at the Edge. Whenever an object this large is discovered falling toward the inner solar system, a very predictable thing happens. Alongside the genuine science, a second story starts to grow, one told in ominous videos and anonymous posts, and it usually goes something like this. They found a giant object heading our way. They are not telling you the whole truth. It is bigger than they admit, or closer than they admit, or aimed straight at us, and the authorities are keeping it quiet to prevent panic. I want to take that seriously, not because it is correct, but because understanding exactly why it is wrong is far more interesting than simply dismissing it. The most common version attaches an old name to this comet, the name Nibiru, or Planet X, a supposed hidden world that doomsday believers have been predicting will destroy the Earth for decades. Every time a notable new object appears in the outer solar system, this myth wakes up and tries to attach itself. So let us just look at the facts directly. The orbit of Comet Bernardinelli Bernstein is not a secret, and it is not vague. It has been measured with great precision, using more than a decade of observations, including those old pre-covery images stretching back to 2010. When you have that many data points spread across that many years, an orbit is not a guess, it is nailed down. And that well-measured orbit says, unambiguously, that the closest this comet will ever come to the Sun is about 1 billion miles, out beyond Saturn in the year 2031. It never crosses the orbit of Jupiter. It never comes anywhere near the Earth. There is no hidden trajectory, no secret course correction. The math simply does not allow it. There is also a quieter logical problem with the cover-up idea, and it is this. This comet was not discovered by a secret government program. It was found by 2 university astronomers digging through publicly available survey data, and the discovery and its orbit were announced openly, published, and handed to the entire world's astronomical community, professionals and amateurs alike. Telescopes all over the planet have looked at this object. If there was something being hidden, it would have to be hidden from thousands of independent observers in dozens of countries, many of whom would love nothing more than to be the one to reveal it. Real astronomy is one of the least secretive activities humans do. The data is out there, anyone with the skill can check it. A second, more modern theory suggests this object is not a comet at all, but something artificial, an alien craft, drawing a comparison to a strange visitor from a few years ago, the interstellar object we called Oumuamua, which really did pass through our solar system, and which really did behave oddly enough to spark serious debate. It is a fair thing to wonder. But the comparison actually highlights why Bernardinelli Bernstein is so clearly natural. Oumuamua was interstellar, unbound, just passing through from another star system, and it was small and oddly shaped. Our comet is the opposite in every way that matters. It is gravitationally bound to our Sun, travelling on a long but ordinary elliptical orbit that belongs to our own solar system. It shows a completely normal, if enormous, cloud of gas and dust, powered by exactly the kind of carbon monoxide ice we would expect from a pristine Oort cloud body. There is no strange acceleration, no unexplained behaviour, nothing that requires anything more exotic than a very big, very old, very dark ball of ice doing precisely what physics predicts. And then there is the oldest theory of all, older than telescopes, the idea that a great comet is an omen, a sign of catastrophe or upheaval, a warning written in the sky. For most of human history, comets were read exactly this way. The famous appearance of Halley's Comet was recorded as a portent hanging over a medieval battle. Great comets were blamed for plagues and the falls of kings. I understand the pull of that instinct completely. A dark giant falling silently in from the edge of everything does feel like it ought to mean something. But that meaning lives in us, not in the comet. Bernardinelli Bernstein has been on this path for millions of years, indifferent to every empire that has risen and fallen while it fell. It is not coming for us. It does not know we are here. It is simply obeying gravity, as it has since before we existed. I want to spend a little more time on why a well-measured orbit is something you can genuinely trust, because this is where a lot of the fear quietly falls apart, and understanding it is empowering. An orbit is not a vibe or a guess. It is a curve fit to observations, and the more observations you have, and the longer the span of time they cover, the more tightly that curve is pinned down. With Bernardinelli Bernstein, we do not have a handful of blurry sightings from last week. We have a decade and a half of precise positions, stretching back to those recovery images from 2010, each one a hard data point nailing the object to a specific place in the sky at a specific moment. When you have that many points across that many years, there is essentially only one orbit that can thread through all of them. The path is overdetermined, meaning we have far more information than we strictly need to solve it. That is why astronomers can state with real confidence that the closest this comet ever comes is out beyond Saturn, in 2031. It is not an estimate they are nervously hoping holds. It is geometry. And consider the practical impossibility of the cover-up itself. For a secret to be kept, the number of people who know it has to be small, and the information has to be controllable. But this comet is the opposite of controllable information. Its discovery came from public survey data. Its orbit was published openly. And ever since, telescopes on every continent, operated by universities, national observatories, and skilled amateurs with backyard setups, have been free to observe it themselves and check the math. If there were some hidden truth about its path, it would have to be hidden simultaneously from thousands of independent people across dozens of countries, many of whom compete fiercely to be the first to announce something new, and none of whom answer to any single authority. Astronomy is, almost by its nature, one of the most transparent sciences there is, because the sky belongs to everyone and anyone with a telescope can look. The reason you have not heard panic from that global community is not that they are all in on a secret. It is that there is nothing to panic about, and they can all see it plainly. Let me also take the alien craft idea seriously for a moment, because I actually think the comparison to that strange interstellar visitor from a few years ago is instructive rather than silly. That earlier object genuinely was from another star system, genuinely was unbound from the sun, just passing through on a one-way trip, and it genuinely did show some subtle behaviour that provoked real scientific debate, so it is not unreasonable to ask whether this comet could be something similar. But the answer is that it is almost the perfect opposite in every measurable way. That interstellar visitor was small, was not clearly a comet, and was gone in a matter of months never to return. Bernardinelli Bernstein is enormous, is unmistakably a comet with a normal coma of gas and dust, and is on a bound, elliptical orbit that belongs to our own Sun, an orbit that will bring it back again in a few million years. It shows no strange acceleration, no inexplicable behaviour, nothing that physics cannot account for with a very large, very dark, very old ball of ice. The contrast does not make it mysterious, it makes it clearly, reassuringly, one of our own. Then there is the deepest and oldest version of the fear, the sense that a great comet must mean something, must be an omen. This one has roots thousands of years deep. Ancient records treated bright comets as harbingers of disaster, the deaths of rulers, the fall of cities, the coming of plague. A famous appearance of one great comet was stitched into a medieval tapestry, hanging ominously over a doomed king on the eve of a battle he would lose. For most of history, a strange light in the sky was read as a message aimed at us, a warning written in the heavens. I understand that instinct in my bones, and honestly, a dark giant falling silently in from the edge of everything is about as good a candidate for an omen as the universe could offer. But the meaning is ours, not the comet's. This object has been on its path for millions of years, utterly indifferent to every human triumph and tragedy that has played out while it fell. It is not a message. It is not aimed. It does not know we are here. It is simply obeying gravity, exactly as it has since long before there was anyone to be afraid. But here is the part I really want you to hold on to, because underneath all the noise there is a legitimate kernel, and it deserves respect. The reasonable version of the fear is not there as a secret killer comet. The reasonable version is a genuine scientific truth, which is that our knowledge of the outer solar system is incomplete, that large objects can and do hide out there, and that we are still, even now, in the early days of finding them all. That is not a conspiracy. That is just an honest description of where we stand, and the answer to it is not panic or secrecy. It is exactly what we talked about a moment ago, the new surveys, the systematic sky mapping, the census that is finally beginning. The cure for the fear of the dark is not to invent monsters in it. It is to turn on the lights, patiently, one discovery at a time, and when we do, what we are finding is not a threat lurking in the shadows. It is something far grander and far stranger, and it brings us back, at last, to the deepest question this whole story has been circling. Part 12. What still stirs at the edge? Let me bring you all the way back to where we started, to that image of something enormous and dark, falling toward us from beyond Saturn, unnoticed for almost the whole of human history. We have spent this entire journey trying to understand that one object, and I hope by now it has transformed in your mind from a scary headline into something much more profound. Comet Bernardinelli Bernstein is not a threat. It is a revelation, and the thing it reveals is not about danger. It is about how little of our own home we have actually seen. Think about everything this single comet has told us. Its impossible size showed us that the Oort cloud holds bodies far larger than many expected. Its pristine carbon monoxide ice, hissing away in the deep cold where water lies frozen as stone, showed us that it is a preserved fragment of the solar system's birth, untouched for 4.5 billion years. Its steep plunging 3 million year orbit showed us that it comes from a vast spherical shell surrounding the sun in every direction, a shell so large our fastest spacecraft would need 30,000 years to cross it. And the simple fact that it was falling toward us at all showed us that the galaxy itself reaches into our solar system, that a passing star or the slow tide of the Milky Way, acting long before we existed, set this ancient giant on its long descent into the light. And then, the deepest lesson of all, this magnificent object, the largest comet we have ever found, is not a singular wonder. It is the tip of the iceberg. It is the brightest and easiest to find member of a hidden population that may number in the trillions. A shell of frozen worlds so vast, so dark and so distant that it makes up the overwhelming majority of our solar system by volume, and yet has never once been directly seen. We confirm its existence one falling comet at a time, and this is the grandest single confirmation we have ever received. So here is the question I want to leave you sitting with, the one this whole story has been building toward. We tell ourselves that we live in an age of completed maps, that the great discoveries are behind us, that our solar system is a known and finished place. But the truth is almost the exact opposite. The truth is that we have thoroughly explored only the tiny bright core, the planets and their moons, a speck at the very centre of something immeasurably larger. And around that speck in every direction lies a dark and silent frontier we are only just beginning to perceive, a shell of trillions of ancient worlds, any one of which could be the size of the giant we have been following, any one of which could, at this very moment, be beginning its own long fall inward, nudged loose by a star that passed while our ancestors were learning to make fire. Comet Bernardinelli Bernstein spent millions of years in the dark, and then it fell, and for a decade or so it will drift silently past the outer planets, while our telescopes drink in every photon it offers, and then it will climb back out into the cold and vanish for another few million years, long after everyone alive today is gone. It asks nothing of us. It threatens nothing. It simply passes, a messenger from the edge of everything, carrying in its ancient ice the story of how our world was built. I think what moves me most about this whole story is the sense of scale it forces on you, both in space and in time, and how small and brief it makes our own moment feel, without making that moment meaningless. Consider the timeline. This comet was formed alongside the planets 4.5 billion years ago. It was exiled to the outer dark before there was complex life on Earth. It has been falling inward on this particular approach for well over 1 million years, since before our species had language or fire. It was quietly photographed by our telescopes starting in 2010, unrecognized. It was finally identified in 2021. It will reach its closest point in 2031, drift past the outer planets, while we study it for a decade or so, and then climb back out into the cold and vanish for another few million years, long after everyone watching this has lived their entire life and been forgotten. Our whole relationship with this object, from first recognition to final farewell, is a flicker, a couple of decades, in a journey measured in the age of the solar system. And yet, in that flicker, we get to understand it. That is the part I find genuinely beautiful. A creature made of the same star stuff as the comet, living on a small wet planet for a handful of decades, somehow developed the tools and the patience and the curiosity to notice a dark smudge falling in from half a light year away, to weigh it, to read the chemistry of its breath, and to trace its path back to the birth of the solar system. The comet does not know we exist, but we know it exists, and we understand, at least in part, where it came from and what it means. There is a strange dignity in that, in a brief fragile intelligence reaching out across billions of miles to comprehend something that will outlast it by an unimaginable margin. I also keep thinking about how this reframes the very idea of exploration. We tend to imagine that the age of great discovery is behind us, that the maps are drawn, that the frontier has closed. And here on the surface of our own planet, in a sense, that is true. But look outward, and the opposite is the case. We have thoroughly explored a tiny, bright inner room, the planets and their moons, and we have mistaken that room for the whole house. The truth this comet reveals is that the house is almost unimaginably larger than the room, that surrounding our familiar little core is a vast dark shell of trillions of frozen worlds, most of them never seen, extending nearly halfway to other stars. The frontier did not close. We simply had not yet developed eyes sensitive enough to perceive how much of it there was. And now, just as this messenger arrives to prove the shell is real and full, we are finally building those eyes. The greatest era of discovery in the outer solar system is not behind us, it is about to begin. So, let me leave you with the thought that has stayed with me through all of this. Somewhere out there right now, beyond the reach of any spacecraft we will ever build, in a shell of darkness that makes up the true bulk of our solar system, there are trillions of ancient icy worlds drifting in the cold. We have directly seen only the tiniest, brightest handful of them, and among them, at this very moment, there are almost certainly others beginning their own long falls inward, nudged loose ages ago by the passing of stars whose names we will never know, silently descending toward the light on journeys that started before we existed, and will end long after we are gone. And when it is gone, the shell it came from will still be there, wrapped around the sun, holding its trillions of secrets in the dark. There is a final thought I cannot shake, and I want to share it with you before we close. For almost the entire history of our species, this comet was there, falling, and we had no idea. Every person who ever lived, every civilization that rose and fell, every astronomer who ever looked up in wonder before our own generation, all of them lived and died while this giant was quietly descending toward the sun, completely unknown. And it is only now, in this narrow sliver of time, that a species finally exists on Earth, with the instruments and the understanding to detect it, to measure it, and to grasp what it represents. We are the first humans who could know this object at all. That is not a small thing. Out of all the generations, ours is the one that gets to meet it, and there is a kind of responsibility, or at least an invitation, hidden in that privilege. Because the comet is only the first clear glimpse. The real work, the mapping of that vast unseen shell, the census of the trillions of frozen worlds at the edge of the sun's reach, is just beginning, and it will unfold across generations. The children being born today may grow up with a catalogue of distant giants that we cannot yet imagine, a genuine map of the outer solar system where we now have only a rumour. We are standing at the very start of that project, holding the first clear specimen, looking out at a frontier we did not know was there. We have found exactly one of its giants by looking backward through old data and realizing the universe had been leaving us a message we hadn't read. Now, at last, we are learning to read the rest. And the real wonder, the thing I hope stays with you long after this video ends, is not the comet that we can finally see. It is the vast, patient, unseen population it points to, waiting at the edge of the sun's long reach, most of it still hidden, most of it still falling, most of it still completely unknown. The largest comet ever found was only ever the beginning of the question. What else is out there in the dark, quietly moving, quietly falling, waiting for us to finally look, is the question that will outlive us all.